Hi, my name is Max Canto. I'm here to talk about hydrogen fuel production, the future of energy. So to start off, I'm just going to talk a little bit about the history of hydrogen. So originally in 1671, the reaction of acids and iron filings were found to create hydrogen gas by Robert Boyle. Not long after, in 1781, the discovery of water production upon combustion of hydrogen and oxygen was made by Henry Cavendish, and that's a really integral discovery right there, and I'll talk a lot more about that later. In 1898, James Dewar was the first to liquefy hydrogen using his own Dewar the vacuum flask, and solidified it actually the next year. In 1852, Henry Gifford invented the first hydrogen-based mode of air travel, soon to be called the Zeppelin. And then in 1977, the nickel hydrogen battery was created by the U.S. Navy and used later on multiple space vehicles. So next off, I want to talk just a little bit about the chemistry of hydrogen fuels. Hydrogen is a chemical element with the atomic number 1 and molecular weight of 1 kilogram per mole, making it the lightest element known to man. As a monatomic ion, it's the most abundant chemical substance in the universe, making up approximately 75% of all mass. Hydrogen fuels are a larger classification of any solid or gaseous mix containing the element hydrogen. In its most basic form, diatomic hydrogen can be produced and combusted in order to create mechanical or electrical energy. So I just want to talk now about the actual production of hydrogen fuels. And basically, there's 2 ways that hydrogen fuels can be produced. I'll say in order to produce hydrogen, there are multiple basic processes that can be used. Fossil fuels represent the largest amount of hydrogen production using steam reformation. This makes up about 95% of the world's hydrogen industrial production. During this process, a hydrocarbon such as natural gas can be introduced to a high temperature steam in order to create a sine gas of carbon dioxide and hydrogen gas, as shown right here on the slide. This process is considered overall the most thermally efficient, with a range of 70 to 85% of total conversion. Another production process utilizes the electrolysis of water. While multiple versions of this process exist, the basic steps include the usage of electrical energy in order to split water into hydrogen and oxygen gases. Depending on the process type, the efficiency of these can vary, reaching a maximum of 70 to 80% thermal efficiency. So next thing, once the hydrogen is produced, we actually want to go into how it's actually used in the modern world. So the largest 2 usages are mostly in vehicles. So once hydrogen is produced, it can be used in multiple ways to produce mechanical or electrical energy. The most basic of the usages are in electrochemical fuel cells or in direct combustion. Hydrogen can be used as an alternative to lithium-based batteries in electric vehicles. In an electrochemical fuel cell, the chemical potential energy of hydrogen and oxygen are harnessed using a proton exchange membrane. As the hydrogen and oxygen molecules react across the membrane, electricity is generated and thus can be used to power electric motors with only water as an emission point. In vehicles, modern internal combustion engines could also be converted to utilize hydrogen gas rather than gasoline as the propulsive fuel. Hydrogen has also been mixed with diesel or gasoline fuels in order to create the combustion efficiency and reduce the harmful emissions. As the storage barriers are surpassed, hydrogen continues to gain traction as a possible fuel addition or source for modern vehicles. Now, hydrogen in many ways is an advanced fuel with a large amount of benefits, though it does not come without its drawbacks. When hydrogen fuels are utilized in vehicles, the only emission is water rather than harmful emissions from a standard internal combustion engine. Even in vehicles that use gasoline, the addition of hydrogen to the combustion chamber can greatly reduce the harmful emissions. The high specific energy of hydrogen is also beneficial as it contains 142 megajoules per kilogram of fuel, compared to methane that only contains 55 megajoules per kilogram of gas. Given this high specific energy, a lesser amount of fuel is required in order to power a system using a fuel with a lower specific energy. The difficulties with hydrogen arise with its storage and net emissions. As a gas, hydrogen is difficult to store and requires either extreme compression or cooling into a tank. As an alternative, hydrogen can be stored as a liquid but still requires supercooling. Also, while hydrogen is a zero-emission fuel when combusted, the production of the fuel uses electrolysis or steam reformation is energy intensive, and if not done sustainably can still be harmful to the environment. Given these difficulties, the future of hydrogen requires continued innovation in order to overcome these hurdles and utilize a fuel of the future. Thank you. Yeet.